2024, you're in for an exciting surprise. For the first time in 8 decades, a star system 3,000 light-years away from Earth will be visible to the naked eye thanks to a once-in-a-lifetime nova outburst. NASA has announced that this massive explosion will be so bright that it will look like a new star in the night sky. Since this is one of only 5 recurring novae in our galaxy, this event is not to be missed. Are you ready to find out when you will witness this magnificent light show and why it's so special? Let's go. For the first time in 80 years, a celestial phenomenon will grace our night sky, offering a once-in-a-lifetime chance to witness a star's brilliance with the naked eye during a dramatic explosion. This star, which resides almost 3,000 light-years away from home in the northern hemisphere's expanse, is known as T Corona Borealis or TCB. Corona Borealis, also known as the Northern Crown, is a small constellation located in the northern celestial hemisphere. It contains a semicircular arc of stars that resemble a crown. The brightest star in the constellation is Alphecca or Gemma, but it will lose its spotlight when TCRB lights up the Corona Borealis constellation, shining as brightly as the famed North Star. What makes this event so spectacular is the fact that it will be visible to the naked eye for an entire week. The last time the star system was seen by people on Earth was in 1946, and NASA believes it will again be visible somewhere between September and October 2024. According to Jonathan Blazek, an assistant professor of physics at Northwestern University, this is an exciting time for amateur astronomers and astrophysicists alike. Although it's not technically a new star, but a star that will be bright enough for people to see, the celestial event will allow us an opportunity to see and understand the cosmos in a new way. But what exactly is a nova explosion, and how is it different from a supernova? If we talk about novas, there's a broad class of these sorts of events, and they usually involve 2 or more objects that are close to each other and in the process of transferring mass from one to the other. The process eventually builds up enough mass on the hotter object, so much so that it ignites. This triggers a fusion reaction, resulting in an intense release of energy that makes the object appear much, much brighter. If we look at TCRB, the nova explosion that Earth is all set to experience this year, it contains a white dwarf and a red giant, 2 stars that create the perfect conditions for a nova outburst. A red giant is created when a star like our Sun runs out of fuel and becomes larger and cooler. The process turns the star red instead of white or yellow like a hot star. On the other hand, a white dwarf is created when a red giant loses even more fuel, turning into a very compact star. When a red giant and a white dwarf star orbit one another, the white dwarf dominates the other, stripping away the atmosphere of the expanding red giant. According to Blazek, the white dwarf is much smaller and much more compact, so you build up a little disk of mostly hydrogen and maybe some helium as well sitting on the white dwarf. Eventually, enough of it builds up and basically ignites. It's not literally burning in the sense of fire. It's a thermonuclear burn, and you have hydrogen undergoing a fusion reaction. The white dwarf, even though it's small, still has a lot of gravity, and what it does is it's stealing the matter from the sun. Most of this is hydrogen, and as it starts to pull that in and around the white dwarf, it creates what's called an accretion disk. As it undergoes a thermonuclear reaction, the white dwarf star turns hotter, bigger, and brighter. This increased brightness of the star allows humans on Earth to witness this magnificent cosmic phenomenon. Interestingly, this entire process is part of the natural life cycle of these stars, and they experience the thermonuclear reaction every 80 years. Once a white dwarf goes nova and wows everyone with a spectacular light show, it goes back to stripping away gas from the red giant until it has built up enough gas for another outburst. But that won't happen for another 80 years. While TCRB is one of 5 nova candidates in our galaxy that we know of, this star is of special interest to astrophysicists for another reason. It's because systems like TCB are prime candidates for Type 1a supernovae. Despite the similarity in names, novae and supernovae are very different from one another in their origins, mechanisms, and consequences. A nova occurs in a binary star system where a white dwarf and a companion star orbit each other closely. The white dwarf continuously pulls material, primarily hydrogen, from its companion until it ignites a thermonuclear explosion. This explosion brightens the white dwarf star significantly, but the star remains just as it is. It is not destroyed, and the process may repeat if the white dwarf continues to accumulate material. On the other hand, a supernova is a cataclysmic event that annihilates a star completely. A supernova occurs in two situations. One is a core collapse supernova where a star's core runs out of nuclear fuel and is unable to sustain its outer layers against gravity. As a result, the core collapses, resulting in a massive explosion that destroys the star. The second is the Type 1a supernova where a white dwarf star accretes material from a companion star, similar to a nova. However, the white dwarf eventually reaches a critical mass, also called the Chandrasekhar limit, that obliterates the white dwarf. TCB's white dwarf will also hit a certain mass after repeated novae from where it won't be able to support itself and collapse. This means the nova that we are so excited to witness this year will actually act as a catalyst for the star's eventual destruction. Do you think there's a chance we witness that too? It's highly unlikely. Novae occur every 80 years, but supernovae are one-time events. They are so powerful that they annihilate the star entirely. Recurrent novae like T Corona Borealis outburst at regular intervals. This characteristic has earned TCB the name Blaze Star. It last exploded in both 1866 and 1946, and astronomers at NASA are expecting the same this year around September and October. While the star usually has a magnitude of +10, which is far too dim to view with the naked eye, the explosion will amp up the magnitude to a whopping +2. That's about the same brightness as Polaris, the North Star. And the timing couldn't be more perfect. The constellation Corona Borealis is one of the most beautiful constellations of all, and it's high in the night sky at this time of the year, so you can expect a brilliant light show that will be visible for several days. Although a nova is a rare sight, it's nothing compared to a supernova. And believe it or not, you might get to witness that event as well if Betelgeuse, the closest supernova candidate star to the solar system, decides to go all out soon. The red supergiant, which is many times the mass of the Sun, is the 10th brightest in the sky. However, it has been acting strange lately with a marked dip in brightness since late January. A supernova hasn't been seen to explode in our Milky Way galaxy since the 17th century. Betelgeuse will inevitably explode as a supernova, but that could occur at any time in the next 100,000 years. While we wait for that, the T Corona Borealis nova is an exciting prospect. Smash the like button, subscribe to our channel, and press the notification bell for more videos.